Let's now talk about processes. A process is a running instance of a launched executable program, and it consists of a number of elements, including an address space that is incorporated into memory, a few security properties like ownership, credentials, and privileges, and it also consists of a process state. Now, the environment of a process consists of local and global environment variables, a scheduling context, as well as some system resources like ports and file descriptors. Let's have a look at the diagram right now. So an existing process, which we call a parent, duplicates its own address space. We call this forking, and it does so to create a new child process structure. Now, every new process is assigned a unique process ID. So that is how we track processes, through their process IDs. So in an earlier chapter, we learned about users and groups and how we identify users and groups, whereby their user IDs and group IDs. How we identify processes would be by their process IDs. Now, the process ID and the parent's process ID are all elements of the new process environment. The parent process ID is often referred to as the PPID. Any process may create a new child process, and all processes are descendants of the first system process, and the very first system process is System D. Now, through a fork routine, a child process inherits its security identities, previous and current file descriptors, ports, and other resources. And a child process may then execute or exec its own program code. Normally, a parent process sleeps while the child process runs. And it does so by setting a request, which is a wait, to be signaled when the child completes. Upon exit, the child process has already closed or discarded the resources that it needs, and the remainder is called a zombie process. And then the parent, when it is signaled awake by the child that has exited, cleans up the remaining resources. As the process runs, its immediate requirements for CPU time and resource allocation may change, and processes are assigned a state. Having a look at the diagram over here, it shows you the different types of states that a process may have. These states include R for running, which means that the process is actually making use of the CPU right now. It's currently being allocated CPU cycles. S, and S typically means sleeping. And we have sub-flags that will further indicate how the process is currently sleeping. For example, it could be in a task interruptible state, which means that it's waiting on some sort of condition. The process is currently alive in your system. It is resident in memory. However, it's currently not making use of CPU cycles. We have T for stopped, Z for zombie. Now, while additional process states exist, we're going to ask that you do a bit of extra reading to get more information.